Hello, welcome to the video. I'm going to show you how to figure out oxidation numbers. Okay, so let's say we have sodium, Na, iodide, NaI. NaI is sodium iodide. And we want to determine the oxidation numbers. Okay, if there's no number there, it means it's a 1, like there's subscript 1. So there's one sodium and one iodine atom. And all you have to do to figure out the charges is to bring them back crisscross like this. So that would mean that sodium has a positive 1 and iodine is going to have a negative 1. So you make the 1 on the right negative, the 1 on the left positive. The metal is going to have a positive charge and the non-metal is going to have a negative charge. When you have a metal and non-metal, it's called an ionic bond. So crisscrossing like this will give you the oxidation states or oxidation numbers when you have ionic bonds like this. So when you have a metal, non-metal, this will work. You just crisscross. So like for instance, MgCl2, magnesium chloride. Magnesium is a metal, chlorine is a non-metal. You can tell by looking at the periodic table. If it's a color-coded periodic table, that you can tell then which are the metals and which are the non-metals. But you have a metal and non-metal, and to figure out the oxidation numbers, you're going to crisscross. This is going to be 1, because there's no number there, and the other one's going to be 2. So you bring the 1 up this way, and the 2 up that way. So magnesium, Mg, has a +2 charge, and chlorine has a -1 charge. So it makes sense because there's 2 chlorines at -1, give you a -2, plus the 2 on the magnesium gives you 0. So overall it should be 0. But these are the oxidation numbers. And so this is a metal's magnesium, chlorine's a non-metal, forms an ionic bond. Metal and non-metals make ionic bonds. And then you can get the oxidation numbers this way. So, okay. So let's say we have an element like this, sodium by itself, just sodium solid, S for solid. It's going to have a 0 oxidation state. In order to get an oxidation number, you need to be bonded with, other than 0, you need to be bonded with something. But that's in free form, it's by itself, so it's 0. Cl2, it's bonded with the same atom, so chlorine to chlorine, so it's going to have a 0 oxidation state. It has to be bonded to something else for you to have those oxidation numbers other than 0. But when it's in free form like this, it's just 0 by itself, right? Chlorine, Cl2 by itself, just 0. Na by itself, just 0. Okay, let's look at something like sulfuric acid, H2SO4. Okay, so group 1 on the periodic table is like hydrogen, then lithium, then sodium, then potassium, and there's more. But it's group 1, so these atoms, when they bond to something else, will have a +1 oxidation state. Group 2, like for instance, you have magnesium. So actually you have beryllium before the magnesium. So you have beryllium, then you have magnesium, then you have calcium, and then you have more, right? But in group 2, you're going to have, you can tell the group because it's just the first group. And it'll have a 1 on top. It has a +1 oxidation state. Group 2, they have +2 oxidation states. Okay, so hydrogen has a +1. And actually what we'll do is we'll put the +1 here. It's just arbitrary. I'm going to put it on the bottom here. You can put it on top. But I usually, when I do this, I just put the overall charge on top. So each hydrogen has a +1, but there's 2 of them, right? So that means you can have overall +2 on this. Then you have this portion here. You really can look at this 2 ways, but let's look at it the first way here first. Okay, so oxygen normally has a -2 oxidation state. So oxygen's normally -2. Negative 2 times 4 would be negative 8. So how do we figure out the sulfur then? The whole thing should add up to 0. So we should say plus 2 plus the sulfur. We make the sulfur x plus, let's see, this is x here, plus negative 8 equals 0. So plus 2 and negative 8 is negative 6. So x minus 6 equals 0. So I add 6 to both sides. X equals 6. That means the sulfur has a plus 6 oxidation state. The whole thing must sum to 0. Okay? That's one way to look at it. Another way to look at it is to look at the polyatomic group. A polyatomic group is just a group of atoms covalently bound together, meaning they're sharing electrons. So SO4. If you look up, you can look up the polyatomic groups on the web. That will give you a list of polyatomic groups. And the sulfate SO4 has a negative 2 charge. And so from the negative 2 charge, you can figure out then what the sulfur is, because the oxygen itself is normally negative 2. So negative 2 times 4 would give you negative 8. So, and if S is unknown, we'll make this X. So we'll say negative 8 plus X equals, the overall charge is negative 2. So this is actually the overall charge in this case is negative 2. So it's not summing to 0 this time because you have a charge on top. So in order for this to be true, X must be positive 6. Minus 8 positive 6 is negative 2. So you can figure things out looking at polyatomic groups as well. So there's a bunch of polyatomic groups, and you can find a whole list of them on the web, and they give you the charges, and then you can work that way. But hydrogen would be positive 1 because it's in group 1. Now, normally, oxygen is normally negative 2, but not always. So let's see. Let's say we have hydrogen peroxide. Oops. Okay, let's say we have hydrogen peroxide, H2O2. Now, oxygen normally has a negative 2 oxidation state. But in this case, it's going to have a negative 1. So this is an exception. Hydrogen's in group 1, so it's going to have then a plus 1 oxidation state. And let me put that on the bottom because I'll put the charge of the individual hydrogen on the bottom, and overall it's plus 2. And I'll put that on top. I just normally do it that way. But the hydrogen's plus 1, but there's 2 of them, so 2 times 1 is 2. Now, this whole thing must sum to 0. So there's 2 oxygens, so each of them must be negative 1 to give you negative 2. Plus 2, negative 2 equals 0. So those are the oxidation numbers, plus 2, negative 2. Or excuse me, plus 1, negative 1. So oxygen is normally negative 2, but not always. Hydrogen is in group 1, so it's plus 1. Fluorine, the most electronegative atom is fluorine. And this is always going to have a negative 1 charge. So this is going to be negative 1 for fluorine. Electronegativity is it's the affinity an atom has for an electron. Okay, so atoms that are further right on the periodic table and higher up have greater attractions for electrons. So the one with maximum attraction is fluorine. We ignore the noble gases. The noble gases are to the right of the column with fluorine, and those have 0 affinity. But so if we ignore the noble gases, then to the right and up, you're going to have more attraction for an electron. So in group 17, where you have fluorine is the first atom, chlorine is the second atom. Now, fluorine normally is going to have a negative 1. Chlorine is normally going to have a negative 1. But if you put the chlorine by a fluorine, then since fluorine has more attraction for that electron, chlorine will develop the positive charge and fluorine will have the negative because fluorine has more attraction for the electron. So let's look at another example. Okay, CO2, carbon dioxide. This is covalently bound. There are two nonmetals. Carbon's a nonmetal, oxygen's a nonmetal, so it's a covalent bond. You don't crisscross like we did with the metal nonmetal. You don't bring the two up to the carbon and the one up to the oxygen. That would be wrong, because since it's covalently bound, we do something different. Each oxygen normally has a -2 charge. Okay, so -2, the oxygen. So -2 times 2 is -4. The whole thing must equal 0. So this must be +4. So +4 and -4 equals 0. So carbon is a +4 oxidation state. Let's do another H3PO4, phosphoric acid. Again, this is all covalent. Here it's all covalently bound. They're all nonmetals, so they share electrons, which means covalent. Now, each oxygen is normally -2, and hydrogen is +1. So you have 3 hydrogens, so you're going to have +3 here. You have 4 oxygens, so that's -2 times 4 is -8. Now, to get the phosphorus here, -8 plus 3 is -5, right? So this must be +5 to give you 0. +3 plus 5 minus 8 is 0. So the phosphorus is going to have like a +5 oxidation state. So hydrogen will have +1, phosphorus +5, oxygen -2. Okay, let's look at another K2S2O3. Okay, so we have a metal here, and this is a polyatomic group, which are nonmetals. So basically, what you could do, if you want, you can just bring this 2 up this way. This whole thing will have a -2. The one on the right it's not +2, because it's the polyatomic group in this case is going to have a -2 because it's on the right in this formula for the compound, okay, or molecule. Now, this here, since there's no number to the, I mean, you have a 2 and a 3 here, but this whole thing's combined, so there's no parentheses with a number like 2. There's no 2 here, meaning there would be like you'd bring the 2 up that way, but there's no number, so it's just 1. So meaning in potassium, so potassium would have a +1, which is a group 1. It makes sense. S2O3 would have this charge, -2. So from here you can figure out the oxygen and the sulfur, or what you could just do is you can say, okay, potassium has +1. There's 2 of them, so that's +2 overall. Oxygen's normally -2, so -2 times 3 is -6. Okay, so so you have to get it to be 0. So it'd be +2, and you have a -6 plus X, like the sulfur is +X. But you actually have 2 of them, so we're going to have to whatever we get, we're going to have to divide by 2. Okay, or you can put just 2x if you want, but let's just put x. So we get +2 minus 6, we get -4 plus x equals 0. So x equals 4. But we have 2 of them, right? So we have to divide it by 2. So each sulfur has a +2 charge, but overall it's +4. So +2 plus 4 and -6 is 0. So the charge on the potassium is +1. The charge on the sulfur is +2. Charge on the oxygen is -2. So it adds up to 0. We take like +1, like here. +1 times 2 is +2. 2 times 2 is 4. -2 times 3 is -6. +2 plus 4 minus 6 is 0. Okay, what about then? Okay, let's look at another water, H2O. Hydrogen has +1, but there's 2 of them, so it's +2. Oxygen, normally -2. So there's 1 oxygen. No number means 1. So +2, -2 is 0. So each hydrogen +1 oxygen, each oxygen -2. Thank you for watching.